first grade teachers. The purpose of this video is to provide you with an overview of the standards, intended pacing, and sample instructional strategies for Unit 1B, extending number sequence understanding to build, compare, and interpret numbers within 120. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 1B. The AKS are the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year to build and deepen student understanding. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. Let's look at the AKS and IOAs we will be teaching in this unit. Unit 1B has two AKS, AKS 2 and 6. Under the AKS, you will find the Indicators of Achievement, or IOAs, that we are teaching at this time. Notice for AKS 2, we are only focusing on the IOAs 2A and 2E. For AKS 6, we are only working on the IOA 6D. You will also see that we have provided you with the state coding at the end of the AKS and IOAs, so that if you were looking up resources on the Georgia DOE website, you are able to find the state IOA that is related to the GCPS IOA. AKS 2 involves solving addition and subtraction problems within 20, explaining the relationship between addition and subtraction, and applying the properties of operations. I want to point out the note for AKS 2. In this unit, students will be adding and subtracting within 10 to solve problems. This AKS will continue in Quarter 2, and we will extend to solving problems within 20. The IOAs go into further detail about the expectations for the standard. In IOA 2A, students are solving problems involving addition and subtraction within 10 using a variety of counting and part-whole strategies. Problems involve a variety of problem types that are relevant and meaningful to students' everyday lives. For IOA 2E, at this time, we are really honing in on the meaning of the equal sign in a true addition or subtraction equation. This IOA will repeat again in Quarter 2, where students will do more work with determining if equations are true or false. You will see in the pacing that this IOA is always clustered with 2A in this unit. AKS 6 is our measurement and data standard, but we are only focusing on one specific piece at this time, asking questions and answering them by gathering information, making observations, and using appropriate graphical displays. In IOA 6D, students will learn how to collect, organize, represent, and interpret data to answer questions about their world, with up to 3 categories. Students are provided with opportunities to create and explore statistical investigative questions by collecting and analyzing data. Now, let's look at the pacing guide to see how the AKS and IOAs have been paced out over the course of Unit 1B. In this top portion of the pacing guide, we see the name of the unit, the big ideas for the unit, and the suggested pacing. Unit 1B will focus on numerical reasoning and measurement and data reasoning. The suggested pacing for the unit is about 3 weeks. In the next box, we see the first AKS and IOA that will appear in the unit. Unit 1B will begin with AKS 6, IOA 6D. The left column of the pacing guide will list the progression through concrete, representational, and abstract strategies. The bullets also indicate the learning objective for the day, as well as suggested manipulatives. The right column of the pacing guide shows the instructional resources that align to the intended learning objectives for each day of instruction. Some days you will see the instructional resources linked for the numeracy components of a traditional teacher-led lesson, like this first day here. Other days, you may notice a task-based lesson, which is your full numeracy block for that day. You see that here on the second day. For IOA 6D, we are starting with an introductory 2 days of instruction. This IOA will continue to be revisited throughout the year. As you dig into these lessons, you will notice that the focus of instruction has shifted to a more student-driven approach using the statistical reasoning framework to provide a richer, more meaningful experience with data. Students will be exploring different ways to organize data from a statistical question into categories of their choosing, make decisions about how to represent the data, and then move into generating their own data collection question and gathering data to analyze and interpret. You'll see that both of these days are concrete and representational, as students will choose either or move fluidly between both while working on these concepts. The majority of instructional time will be spent on IOA 2A, which is clustered with 2E. We are suggesting about 10 days of instruction. You will begin at the concrete level using manipulatives like counters and snap cubes to model and solve joining and separating result unknown problems, focusing on counting all, counting on, and counting back strategies. Instruction will progress to the representational strategies, where students will draw a picture or use a number line to help them solve addition and subtraction problems within 10. You'll see that we revisit concrete manipulatives and connect to representational strategies as different problem types are introduced, like part-part whole, change unknown, and compare. We are focusing on building these counting strategies from counting all to more efficient counting on or back strategies while solving addition and subtraction problems within 10. Chapter 3 of the video will highlight specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards document for guidance on additional instructional strategies for each IOA. I am going to highlight strategies that will be used for IOA 2A, solving addition and subtraction problems within 10 using a variety of strategies. Let's take a look at one of the problems from a lesson in Unit 1B. Austin had 5 video games. His mom gave him 2 new games for his birthday. How many games does Austin have now? So as we think through and make sense of this problem, a part-whole model will be helpful for students to see what parts they know and what parts are the unknown in this problem and make sense of this situation. So we know that Austin had some video games, and then his mom gave him some more video games. And what we're looking to find out is how many games Austin has now in all. So that's our total or whole. That's our unknown. The 5 video games Austin had is one part, and the 2 that his mom gives him for his birthday is the other part that make up that whole. This will also help students generate an equation to represent this situation. So we have the 5 games that Austin had, and since his mom gave him 2 more, we know we are going to add those 2 to help us figure out the unknown, that total sum, the number of games that Austin has now. So one way students may approach this problem is using concrete manipulatives like counters, where they can model both parts of the problem, the 5 video games that Austin already had, and then the 2 more games that his mother gives him for his birthday. Now from here, students may choose to count all of the counters to find this total. So they may count 1, 2, 3, 4, 5, 6, 7 to find the total number of games. That would be the counting all strategy. Or some students may move forward into a more efficient way of counting, which would be to recognize that I already know this amount is 5. So we can say 5 and count on the 2 more, 6, 7 to get that total. So counting all or counting on using those manipulatives. Another way students might approach this problem is at the representational level. So they may choose to draw a picture to represent the 2 amounts in this word problem. So something simple like circles or dots, 2, 3, 4, 5, the 5 video games that Austin had, and then drawing 2 more circles to represent the video games that his mother gave him for his birthday. And again, students can find the sum by either counting all, 1, 2, 3, 4, 5, 6, 7, or move to a more efficient counting on strategy, saying 5 that we know, 6, 7 to find that total sum. Another representational strategy that students might choose to utilize would be using a number line, where we can look at our number line and recognize that we start at 5 video games that Austin already had. They may count up by ones, 1, 2, 3, 4, 5 to get to that 5, or go right to the 5 games and then make 2 hops on our number line for the 2 games that his mother gave him to land on that sum of 7. As students are using a variety of strategies to solve this problem, it's important to help students make connections between these concrete and representational strategies to see how they all represent this word problem and help us find the answer to the question being asked and get that sum of 5 plus 2. So it's important to make connections between the strategies that students are using. Let's take a look at another problem from a different lesson on our pacing guide. This problem is going to be a change unknown problem. And so working with this problem type with these smaller numbers within 10 will help to make this concept more accessible to students, and then will be extended in quarter 2 with change unknown and start unknown problems when you're adding and subtracting within 20. May has 5 books. She checks out some more books from the library. Now she has 9 books. How many books did May check out? Okay, so again, let's use that part-whole model to help make sense of this situation and determine what our unknown amount is. So I know that May had 5 books. And then she checks out some more books from the library, but I don't know right now how many books she checked out. I do know that now she has a total of 9 books. So those 9 books that she has now is the whole amount, or the total. May started with 5 books. So my unknown here is one of the parts. That part represents the number of books that she checked out from the library. So when I'm writing my equation to represent this situation, I know the 5 books that May started with. And then since she checked out some more, she's getting more books. I know I'm adding some amount that's unknown, and that will be equal to the 9 total books that she has now. So this is a change unknown problem where we're joining 2 amounts, but one of those amounts is unknown to us. So one way students could approach the problem is with those concrete manipulatives. So in this situation, they can begin by modeling the 5 books using 5 counters that we know May has. We are going to need to count on up to 9 to find out how many more books she checked out from the library. So here students may recount, or knowing this amount is 5, may count on from the 5 books May had, 6, 7, 8, 9. I know I need to stop at 9 because 9 is the total amount of books that May now has. So with these manipulatives, when I'm looking for the answer to this question and I'm trying to find this unknown, I will look at the number of counters that I counted on from 5 to get to those 9 total books. And I can see that I needed 4 more counters. So that means that May checked out 4 books from the library. Now, another way students might approach this change unknown problem could be to draw a picture. So they may draw 5 circles to represent the 5 books. And I like to circle them here just to keep them separated. The 5 books we know May had. And then I continue drawing circles, counting on from 5 up to 9. So 5, 6, 7, 8, 9. So I can see these circles here represent the books that May checked out from the library, which is again those same 4 books, just like when we modeled with the counters. Another representational strategy that students may utilize is our number line. So here on our number line, I can begin at the 5 books I know May has, And I know I need to count on and count up to the 9 total books that she has now to find my unknown, the number of books she checked out from the library. So I can start at 5 and count up to 6, 7, 8, and 9. I'll stop at 9 because that's my total amount, my whole amount. And I can see that I needed to make 1, 2, 3, 4 hops, right? Could even label these on top of the hops to see, oh, how many books did May check out from the library? She checked out 4 more books. So it's important to allow students that flexibility to choose from a variety of strategies that make sense to them when solving these different problem types. And then we can make that connection between our concrete and our representational strategies to see the similarities between each one as well as those differences, but how they helped us all reach that unknown amount of how many more were added on to 5 to equal 9 to find out those 4 books were the number that May checked out from the library, that change unknown. The Georgia DOE's comprehensive grade level overview states, in mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. Thank you for joining us for this unit at a glance.